Hi, this is Mrs. Nelson. This is Unit 1, Lesson 7, From Parallelograms to Triangles. The objective says, I can explain the special relationship between a pair of identical triangles and a parallelogram. On the grid, draw at least 3 different quadrilaterals that can each be decomposed into 2 identical triangles with a single cut. Show the cut line. One or more of the quadrilaterals should have non-right angles. So, quadrilaterals. When I hear that, I think of squares and rectangles. So I can certainly use those, but that last part says one should have non-right angles. So I'm going to have to draw a quadrilateral that's not a square and it's not a rectangle. Well, I'll start with my square. This is classified as a square because all sides are the same length, all angles are 90 degrees, and it's quadrilateral. I can draw, since it's a square, it's also a rectangle, and therefore also a parallelogram. And I can connect 2 opposite vertices, and if I do that, then I make 2 triangles that are exactly the same shape and size. Well, I can do the same thing if I have a rectangle that's not a square. So in this case, this is a rectangle and not a square because not all the side lengths are the same, but yet there's 4 90-degree angles, and it is a quadrilateral. It's a parallelogram as well. So this is a rectangle that's also a parallelogram. I can do like before, and I can connect 2 opposite vertices, and I will make 2 triangles that are exactly the same shape and size. Notice you'll have to take this triangle right here, and you'll have to rotate it around and set it on top of itself. It's not like pulling it off and just moving it to the side. So it's a little harder to see because you do have to have that rotation in there as well. Okay, so now I'm going to satisfy that last one that has non-right angles. So I'm going to make a parallelogram that's not a square and not a rectangle. So a parallelogram is a quadrilateral, just like squares and rectangles, with 2 pairs of parallel sides. Notice it says nothing about the angles, so we don't have to worry about square or corner angles, 90-degree angles. So we can make acute angles and obtuse angles as part of our parallelogram. So I'm going to draw a line segment that's the same length as one of the sides from the square and the rectangle. And for that matching opposite side, I'm not going to drop it below like with the square or the rectangle. I'm going to shift it to the right. And then I'm going to connect those opposite or those vertices on the sides. And you'll notice that both of these sides, these opposite sides, are parallel. If I extended those shorter sides forever, they would never intersect. If I extended those other sides, the longer sides, forever, they would never intersect. So they are parallel. So this is a quadrilateral that has 2 pairs of parallel sides, so it's called a parallelogram. So like before, I could connect the 2 opposite vertices, so I could connect it this way, and make 2 identical triangles, but I'm actually just going to use this vertical grid line as an easy way to track that cut, to make that cut even easier. So I've made 2 pairs of 2 identical triangles that are exact same shape and size. Notice that this triangle that I used in the rectangle that had the same dimensions of the base. So 3 units here, 3 units here, we've got 3 units here and the 3 units here. This triangle is exactly the same size as this triangle. And this other triangle would be the exact same size as this triangle. So these 2, this rectangle and this parallelogram that's not a rectangle, they take up exactly the same amount of space. Those 2 have the same area. All I've done is decompose and rearrange this rectangle to make this parallelogram, like we've seen before. That's how we figured out how to find the area of a parallelogram. We decomposed and rearranged to make it into a rectangle, and we already knew how to work with rectangles. So the purpose of today is to recognize that relationship between the triangles that make up the parallelogram. So just like before, when we considered that a parallelogram can be decomposed and rearranged into a rectangle, we can also consider the number of triangles inside of this parallelogram. So that question that just rewords our objective says, what is the special relationship between a pair of identical triangles and a parallelogram? Well, I can take any parallelogram, whether it be a square or a rectangle or a parallelogram that's not a square or a rectangle, and I can connect 2 opposite vertices, and I will decompose into 2 congruent or identical triangles. So any parallelogram can be decomposed into 2 identical triangles. which means we can think the other way around, that two identical triangles can be paired together to make a parallelogram. So that relationship is one parallelogram is equal to two triangles, or two triangles is equal to one parallelogram. And like we reasoned before with parallelograms and decomposing and rearranging into rectangles, we can think about triangles and their relationship to parallelograms in order to understand how to find the area of a triangle, which is what we'll do next. Thanks for watching.